In this video, I'll discuss about parallel binary adder or subtractor using full adder block and XOR gate. So I'm going to implement a parallel binary adder or subtractor with the help of full adder and XOR gate. Before starting with parallel binary adder, I will first explain this simple block. So here we can see that there is a full adder. Full adder is a circuit which accepts 3 inputs and produces 2 outputs, sum and carry. Here the 3 inputs are, one input is A, another input is B, and another input is carry input. So along with this full adder circuit, here I am using a special gate known as XOR gate. I will tell you the use of this XOR gate. So as we know in XOR gate, when both the inputs are same, output is same. That is for 0, 0 and 1, 1, output is same. If any one of the input is 1, that is if it is 1, 0 or if it is 0, 1, the output of XOR gate will be high, that is 1. So here, suppose if this input is 0, the whatever the input we take for B, the same will be displayed here. For example, if I take B equal to 0 and here it is 0, 0, 0 will be 0. So same, the 0 will be appear here. If I take this as 1, so in this case it is 1, 0. So 1, 0 it will be 1. So it will be 1. So here the input to the full adder is controlled by this value. If this is 0, the value of B, the same thing will be displayed here. And in this case, if I take Cin equal to 0 at the beginning, the content of A will be added with 1, will be added with 0 and produces sum and carry. So in this case, this full adder is performing addition operation. Now I will make, so now I can say that if this input is 0 and Cin is 0, this circuit acts as adder. This circuit acts as adder. Now let me take this input as 1. I will take this input as 1 and this input as also 1. This input as also equal to 1. So now when we choose this input as 1 and Cin equal to 1, this circuit acts as a subtraction. The subtraction is done using 2's complement addition. So we know that 2's complement is obtained by adding 1 to the 1's complement. That is, we know that 2's complement is equal to 1's complement plus 1. Now let's see how this circuit acts as a 1's complement plus 1, that is 2's complement. Suppose if I give B equal to 0, here now we can observe that 0 and 1. So 0 and 1 is nothing but 1. The output of the XOR gate is 1. Here we can observe that input to the XOR gate is 0, but output is 1. There is 1's complement. If I take B is equal to 1, now 1 and 1, that is 1, 1 will be 0, output will be 0. Again here we got 1's complement of the input. The input was 1, but the output is 0, that is 1's complement. Now whatever the input of A, that A bit will be added with either 1 or 0, and again in turn it will be added with Cin, which is equal to 1. That is nothing but 1's complement, that is 1's complement plus 1. That entire thing will be added with A and produces sum and carry. Thus this circuit, this entire circuit, when it is 1, it performs a subtraction. The subtraction is done using 2's complement addition. Now here I will take one simple example for subtraction. Let A is equal to 1 and B is equal to 0. Let's perform A minus B. So here A minus B will be done using 2's complement addition. So here I have chosen A is equal to 1. This is A is equal to 1. So 1 will appear here. B is equal to 0. So for subtraction this should be 1. So 0, 1. 0, 1 is nothing but 1. Output is 1. The output of this is 1. So here 1's complement is done. Now this full adder will add 1 with this 1 and with this 1. That is 1 plus 1 plus 1. That is 1 plus 1 will be 0, carry 1, and again it will be added with 1. That is, it will be added with 1. 0 plus 1 will be 1. So this carry will be neglected. so that now we can see that the output sum is equal to 1. That is 1 minus 0, it gives result as 1. Now let's see 1 minus 1. That is, now let me take b is equal to 1. If I take b is equal to 1, here this will be 1. The output this will become 0. It will be 1 plus 0 plus 1. That is 1 plus 0, which is equal to 1. And this is 1. That is 1 plus 1. 1 plus 1 will be 0. Carry will be 1. This carry will be ignored. So that now the result sum will be equal to 0. So 1 minus 1 will be 0. So likewise, it will perform the subtraction using 2's complement addition. Now here in this circuit we can observe that whether this circuit acts as a adder or subtraction, that is depending on this bit. If this bit is 0, then if this bit and Cin is 0, this acts as a adder. If this bit is 1 and Cin is equal to 1, this circuit acts as a subtractor. Now I can connect this pin and this pin because both values are same, so I will short these two pins. Now this acts as a control pin. If this pin is 0, this pin is 0, it performs addition. If this pin is 1, this performs subtraction. So now by considering this basic operation, now we can extend this 1-bit full adder to the 4-bit full adder. Now let me draw the 4-bit parallel adder or subtractor. So here I have extended the same full adder block, that is 4 times. All are cascaded. So here I can see this is seen. Now as I said, now it is connected to one of the input of XOR gate. Here it is connected one of the input to the XOR gate. One of the input is connected to XOR gate. One of the input is connected to XOR gate. Here let me take this as A0, that is A1, this is A2 bit, this is A3 bit. That is, I have two numbers A and B. A has 4 bits, say if A3, A2, A1 and A0. B has 4 bits, those are B3, B2, B1 and B0. So here already I have considered A0, A1, A2, A3. Let these be B inputs. So this is B input. As I told here, this is B input. So this will be, let me take this as B0, this as B1, this as B2 and this as B3. So another input is here, one of the input is control input. Here these all another input of the XOR gate, all inputs are shorted and it is connected to this pin. It is connected to this pin. Now if Cin is equal to 0, it will perform, that is now this Cin, if it is 0, it will perform addition operation, and if it is 1, it will perform subtraction operation. That is, if Cin equal to 0, it performs addition, and if Cin is equal to 1, it will perform subtraction. So when this full adder, the first full adder produces the output sum S0, this as sum S1, sum S2 and sum S3. It will produces the first carry out. I will represent it as C1, which acts as a, this I will take it as CO, which acts as a carry input for the next full adder. The carry input, which is nothing but C1. So here the output of this full adder is CO. The input, this acts as the input for this one, that will be C2, and this produces the output as CO. The output, carry output of this acts as the input for this. I will represent it as C3. The final carry out, I will represent it as Cout. So this is the complete block diagram for the 4-bit parallel adder or subtractor. That is, adder or subtractor is decided by this Cin pin. That is, if Cin pin is 0, it performs addition operation. If Cin pin is 1, it performs subtraction operation. Let me take one example to explain addition and subtraction. Let me take A is 1 0 0 1. Here this is A3, A2, A1, A0. That is A3 is 1, A2 is 0, A1 is 0 and A0 is 1. Let B is equal to 0 1 0 1. So here let B is equal to 0 1 0 1. First let me do the addition operation. So if we add 1 0 0 1 is nothing but 9, 0 1 0 1 is nothing but 5, 9 plus 5 is 14, which is 1 1 1 0. So let me verify this. So here we are performing addition operation. It means Cin must be equal to 0. So here this is 0, this input is 0, this input is 0, this input is 0, this input is 0. So now the output of XOR gate is 1 here. Here the output of XOR gate is 0, 0 is 0. Here output of XOR gate is 1. Here the output of XOR gate is 0. So now this 1 will be added with 1. 1 plus 1 is sum is 0, carry is 1. So 1 plus 1 plus 0, that is 1 plus 1 plus 0. It gives sum as 0, carry as 1. That is 1 plus 1 is 0, sum is 0, carry is 1. That is yes, 0 will be 0, carry will be 1. So this carry acts as input for this. So this 1 will appear here. Now this 0 plus 0 plus 1, that is 0 plus 0 plus 1 is sum is 1, carry is 0. So now here this 0 plus 1 is 1, 1 plus 0 is 1, that is sum is 1, carry is 0. So now here 1 plus 0 plus 0 is nothing but sum is 1, carry is 0. So we got the result here as 1 1 1 0, which is same as this one. So thus addition operation is verified. Now perform subtraction operation between these two inputs. So now if I perform A minus B, so here this is 5, this is 9, this is 5. 9 minus 5 is 4. That is 1 minus 1 is 0. 0 minus 0 is 0. 0 minus 1 is 1. Carry is 1. 1 minus 1 is 0. The result is 4. That is 9 minus 5. The result is 4. Let me verify this. So now for subtraction operation, Cin must be equal to 1. So here now Cin is 1. So 1 input. So this is 1. It is connected here. This is 1. This is 1 and this is 1. So here we can observe that XOR gate 1 1 means output is 0. That is here we got 1's complement. 0 plus 1, the output 0 and 1, the output is 1. It is 1's complement. Here the output will be 1 and 1 will be 0. Here it will be 0 and 1 is 1. So now here we can see that 1 plus 0 is 1. 1 plus 1 is 0. Carry is 1. So now here 0 plus 1. 0 plus 1 is 1. 1 plus 1 is 0. Carry is 1. So now here 0 plus 0 is 0. 0 plus 1 is 1. Carry is 0. So now here 1 plus 1 is 0. 0 plus 0 is sum is 0. Final carry out is 1. So now final carry out will be discarded. So the result will be S3 equal to 0. That is 0. This is 1 0 0. That is 1 0 0. So thus the subtraction is also verified. This is how this complete circuit will act as addition and subtraction. That is parallel addition or parallel subtraction, that is dependent on this Cin bit. If it is 0, it performs addition operation. If it is 1, it performs subtraction operation. Thank you for watching.